Okay, welcome to another CDP Labs Edu Services SAT lesson. I hope you had enjoyed the last one. I hope you had learned from the last one. So without any further ado, let's get into this morning's lesson, all right? Let's go. So today, we're looking at another SAT lesson, and this one is looking at systems of equations. All right, so for this question, it says, which of the following systems of equations has an infinite number of solutions? Now, for me personally, I love to, point my students to looking for keywords in the question, and of course, to define these keywords. Now, this is a key phrase, rather, systems of equations. So we're going to look at the definition of systems of equations, and then we'll look at the definition of the word systems. Why are they called systems of equations as well? Then we're going to look at use different graphs to illustrate each set of equations, and for you then to compare and to be able to see why we arrive at the answer that we arrive at. All right, so let's now look at the definition for systems of equations. Now, here's the definition for systems of equations. You can pause the video and read for yourself. How about that? Now, it says a system of equations is a set of two or more equations. A set of two or more equations. So now we can see this has two equations. Option B has two equations. Option C has two equations. Option D has two equations. So a system of equations is a set of two or more. So you can have more equations, right, that share, and note, that share the same variables. So now we're going to be looking at these set of equations and to see if it illustrates the definition. So note, they must share the same variables. Now, what do we mean by variables? Of course, the variables are represented by the letter X and the letter Y. And in another lesson, we can speak more about variables, right? I'm tempted to teach more about variables, but this lesson is not about variables. Now, the goal is to find the exact values for these variables that make all the equations in the system true at the same time. How are we going to see that? All right, we're going to see that true at the same time. But what do they mean by true at the same time, or an equation being true? An equation being true simply means, then, for example, if we put a value, let's look at the one in D. If we put a value 0 for x, now half times half times you're going to give you 0, so therefore making y equal 5. So y is equal 5. So if y is 5, wherever I see the letter y, I'm going to put 5. So this means 4 times y, which means 4 times 5, which is 20. So 4 times y will give us 20. Now, therefore, it means on the other side of the equation, the equal sign, this must be, so we are saying that x is 0, so 2 times x is 0, plus 20 is 20. So therefore, both equations are true at the same time. So let's proceed further. Now, but we must look at the definition for the word system, right? Let's look at the definition for the word system now. Why is it called a system? Now, a system is a group of interacting, interdependent parts. So they interact, they interdepend, mean that they depend on each other. The interdependent parts that work together to form a unified whole or serve a specific purpose. Now, they are saying if you change or remove one part, the entire system changes its behavior. And of course, we can experiment with this in another lesson. Today we'll not be experimenting with this in today's lesson, but look for the next lesson. We can experiment with it some more. Now, key parts of a system, components. The individual pieces are parts that make up the system. So we have the individual equations that makes up the systems of equations. Interactions, how the parts connect. So they share the same what? Look at the definition again. They share the same variables. So they connect by sharing the same variables. Purpose, overall goal or job that the whole group achieves together. So they intersect. They're working together at that same point. Good. So it is why I did this is to tell you as my students, all my CDP Labs Edit Services subscriber, that guess what? It is important to define the words used in an exam question, so you can have a better idea and a better appreciation for the question itself. Now, if this information is useful for you, subscribe to the channel. If this information is useful for you, click on the like button. Alright, now let's look at each of the answers illustrated in a graph. Now this one is option A. So if you notice now, let's look at the equation again. X is equal to -5, y equal to 10. So in this, so we have this blue line here is representing, y equal 10, and of course x equal to -5. If you note, they share a similar point right here. They share this point. Good. So it is a system of equation. So they share this point together. They are sharing that point. They are sharing that point. Good. Now let's go to B. So we have equation here, x equal 10y and y equal 10x. So here, as you can see, they both intersect at 0. So they are sharing. So when x is 0, y is also 0. So they share the same value. Right? Again, it's a system of equation. Let's look at C. C, there's no sharing. So they are not working together. Therefore, it's not a system of equation. Good? It's not a system of equation. Right? And therefore, these two doesn't work together. They're not sharing any point. They're parallel, but they're not sharing any point. Let's go back to what the question asks us. The question asks us, which of the following systems of equations? So we know now that C is not a system of equation. This is out, all out. Has an infinite number of solutions, and we'll have to look at the word infinite there. So infinite means they have more than 2, more than 3, multiple, never non-stop number of solutions. All right. So far our graph show that A only has one solution, B only has one solution, C has no solutions. So let's look at D. Let's look at D. Now, if you notice, you have two separate equations here, but they share the same line. They are on the same line. Good. Now, when this, I'll use the term collinearity of the systems of equations. Right? Now, let's see if it matches the answer, infinite number of solutions. Now, when x, let's say, when x is 0, y is 5. Let's see. So when x is 0 right here, y is equal to 5. So y is 5. When x is equal to 0 right here, then let's see what y is equal to. So 4y is equal to 20. Why I said that? because when x is 0, 2 times 0 will be 0. So there is no x right here. So to find y, we'll have to now divide 20 by 4. And our answer will be what? 5. So this equation, y is 5, y is 5. The same value. They are sharing the same x value, the same y value. That's one solution. Let's look at another one. What happened when x is 2? So when x is 2, y is 6, right? If x is 2, y is 6. So take a good look at this now. So when x is 2, so half times 2 give us what? 1. So 1 plus 5 is 6. So y is 6 right here. Now, when x is 2, we get what? 2 times 2 is 4. So 4y in this case will equal to 24. So the question is then now, what would y then be equal to? 6. So when x is 2, y is 6. When x is 2, y is 6. Now that is more than one solution. And if you go anywhere along this line, they will have multiple solutions. So this one definitely matches it. Have a multiple solutions, infinite number of solutions. So guess what? Now we have to if you get a question like this in the SAT exam, then you can use a graph to help you to determine whether your answer is right or wrong. So therefore, what we do is to produce graphs for each of them, and in our next in one of our live sessions, you can join our live sessions and come and learn how to do all of this. So let's wrap it up now. Let's wrap it up. So here again, we look at the definitions now. Because when equations are described as collinear, it usually means they are coincident equations, meaning they represent the exact same straight line. And you saw that. In mathematics, the term collinear strictly applies to points lying on a single line. But when applied to linear equations, it indicates that the equations are multiples of each other. So you saw where the y equal half x plus 5, then you saw 4 times y. So it's a multiple of each other. Good. And graph as one single overlapping line with an infinite number of solutions. So once the equations are collinear in definition, then naturally it will have an infinite number of solutions. Of course, understanding collinear equations. Same line, the equations describe the identical path on a graph. Infinite solutions. Any point that works for one equation also works for the other because they overlap completely. Any point that works for one equation also works for another because they overlap completely. Proportional coefficients. One equation can be multiplied or divided by another to become the other equation. And we saw that. Right? So, there you have it. I hope you enjoyed this lesson. And of course, if you enjoy this lesson and you want to join our free 3 weeks classes live session, click on the link in the description for this one. Take care. Peace out. One more time. Wow, good. God bless you.